Mod 1, Topic 7, Absolute Value Equations and Inequalities. Make sure you have your note sheet with you. By the end of the video, should be able to answer why does the solution to an absolute value inequality or equation typically result in a pair of equations or inequalities? And you should be able to write and solve absolute value equations and inequalities. Absolute value is the distance from 0 on a number line. Cannot highlight this one enough. When I ask you, what is the definition of absolute value? This is what I'm looking for. It's the distance from 0 on a number line. It's always positive or 0. It can never be negative value. When traveling distance is always positive. Absolute value uses these bars as a symbol to indicate absolute value. Key points to remember when solving equations. The absolute value of x can never be negative. The absolute value of x is equal to -4. That is not possible. When solving, you must isolate the absolute value of x part. Once the absolute value of x is isolated, set equal to plus and negative value. So for example, the absolute value of 3x equals 15. That's going to be true when 3x equals 15 or 3x equals -15. So once we have the absolute value by itself, we can set it equal to the positive and negative value. Thinking on a number line, the distance away from 0 would be at positive 15 or -15. And we solve both. Key points to remember when solving inequalities. Okay, this is the one for inequalities. Everything the same as solving equations. We just need to flip the inequality and when we make it negative. So the same rule will apply. Flip the inequality if you divide by a negative. So if we have the same scenario, but we have this inequality, you'd still set up two inequalities to solve. But when we have it equal to -15, notice that inequality must flip when we set it equal to the negative value. So absolute value of x equals 5. Distance from 0 on a number line. How far away is 5 from 0? Well, we get positive 5. And if we count the other direction, we would land at -5. So the absolute value of x is at 5 or -5. Absolute value functions can have up to 2 solutions. Absolute value, again, is distance from 0 on a number line. When we're solving absolute value inequalities, the absolute value of x is less than or equal to 5. Looking for a range of possible solutions. Where on the number line is the distance from 0 less than or equal to 5? So we know we have our starting points could be at -5, +5. When's the distance going to be less than that amount? Well, that's going to be in between these numbers. So when x is less than or equal to 5, and when x is greater than or equal to -5. You might write this. Well, I want you to notice the inequality flips for that -5. And notice this format, where we can put x in the middle. We got our smaller number, -5, positive number, 5 over here, and those inequalities are going the same direction. Absolute value of x equals -10. No solution. Remember, the absolute value can never be negative. Solve for the value of x. The absolute value of 2x minus 3 equals 1. Again, absolute value is distance from 0 on a number line. Absolute value is already isolated for us, so we just need to set it equal to a +1, -1, because those are our two numbers that are 1 unit away from 0. So we set 2x minus 3 equal to positive 1 and 2x minus 3 equal to negative 1. And let's solve each one. Divide by 2, we get x equals 2. Add 3 to both sides, divide by 2, and we get x equals 1. These two solutions would satisfy this absolute value. If we plug them back in, 2 times 2 is 4, 4 minus 3 would be 1, absolute value of 1 is 1. If I put a 1 in here, 2 times 1 is 2, minus 3 would be negative 1, and the absolute value of negative 1 would be positive 1, so both solutions would check out. Let's solve this absolute value equation. Let's isolate the absolute value. So we need to get x plus 6 by itself. So let's subtract 8 from both sides. Now we need to divide by 3 to get rid of the 3. So we divide by 3 on both sides. So we have the absolute value of x plus 6 equals negative 1. Hold up. When this happens, there's no solution. Cannot go any further than this because the absolute value can never be equal to a negative. So be mindful for this when you're solving your absolute value equations. If we're solving inequalities, this is going to be the same as our equation, but notice how it's less than 1. Absolute value is already isolated, so we're going to go just like we did with the equation. 2x minus 3 is less than 1. And we're going to have to say 2x minus 3 is greater than negative 1. We solve each one. Divide by 2. So we get x is less than 2. Add 3 to both sides, divide by 2. And we get x is greater than 1. So what you saw in this graph before here is, hey, when's the distance going to be within 1? It's going to be at negative 1 or positive 1. This is the graph that was showing you, that's giving you an indication as to how to set up our equations. What values am I going to set them, the inequalities equal to? These are my two solutions. X is less than 2 and x is greater than 1. So if I graph these, we're going to have a open circle at 1, open circle at 2, and they are connected together. All right, let's solve this one. We need to isolate the absolute value. So we subtract 8 from both sides. Then we're going to divide by 3 on both sides. This time we're good. We have absolute value of x plus 6 is greater than or equal to 4. When is x plus 6 more than 4 units away from 0? Well, it's going to be a positive 4 or negative 4. So we can say x plus 6 is greater than or equal to 4, and x plus 6 is less than or equal to negative 4. This graph is just telling me what I should be putting here at the end of my inequalities. So we'll take that away. We'll solve each one. So we get x is greater than or equal to negative 2, and x is less than or equal to negative 10. So we'll go left of negative 10, close circle because we have our equal to, and greater than negative 2. So again, because those arrows are going opposite, this would be an OR situation.